Okay, that brings us to 11.8, the last one of the regular exercises. So here we need to compute some mean and standard deviation functions of our bacterial group dataset. Okay, so let's look at that. So it's the same file. So here, same file. So we got threshold exceeded. That's perfect. And now let's call the other functions. So get mean of A and get standard deviation of A. Let's call this for M for mean, and let's call this for S for standard deviation. And then what I'm going to do is I'm going to insert some breakpoints here. So that's number 3, and here it is also going to be number 3, like this. Okay, so let's start in the debugger, and then we'll hit the breakpoints, and now we need to solve the exercise. So what we want to do eventually is that we want to, for each of the time points, we want to compute the mean across all the experiments for that time point. So remember, in this data matrix, we have the experiments along the vertical axis, and we have the time points along the horizontal axis. So the first mean we want to compute is basically the mean over all of these numbers here in the first column, and then the second mean is the mean over all of these, and so on and so forth. And I just happen to know that there is a mean function that we can give a dimension argument, just as there was a sum function and the rest, and that'll compute the mean over columns. That's just how it works. And it sort of corresponds to our experience from the previous exercise, that the first values are smaller and then they seem to generally increase, although it's not like monotonically increasing for all the experiments. So that should actually do the trick. Yes. Now we get to data.standard deviation. So again, I'll insert a breakpoint. Let's remove this one. There is a standard deviation function. Let's not get too creative, we'll just use that. And as before, it accepts a dimension argument. It just basically does what we need to do. So all we really need to, you can look at Wikipedia what the standard deviation is. It's a measure of how spread out your data is. That's relevant from statistics, but I don't think it makes a lot of sense to discuss it here. This is how you can compute it. Actually, I think you're familiar with this from high school. Otherwise, you'll certainly be familiar with it pretty soon. Okay, so the last thing is that we need to reproduce this plot. So the way I'm going to do that is I'm going to put in a breakpoint here. And then let's start doing the plot. So we first import matplotlib, and then we can start by plotting the mean, and we just say that's a black line. And then let me select these lines and run them, Shift-Alt-D. Oops, I need to also get this line because I need the import, otherwise it says that it's missing. Okay, so that's the mean. And then we need to plot the mean plus the standard deviation. So we can do that by and let's make it red. And let's just start there. So that's one of them. And then we do the other one. Here we subtract the standard deviation. And that does something. I'm debating if I should plot the data. I guess we could. There's probably an intelligent way of doing it, but here's how we could also plot the data points. So we could have a for loop. Let's actually just use the dimension from the data matrix. So remember, this is how we get the number of experiments, because shape gets the size of the matrix, and then we can get the ith experiment like this. These are the data associated with the ith experiments, and then we can do plt.plot. So we want to plot the data points in each experiment along the y-axis, right? So we need to get the x coordinates of this experiment. So we can just we can use np.arange, because remember that will give us 0, 1, 2, and so on. That's what we have on the x-axis. And then we can give it a.shape of 1. And then we can plot the x's. And I think I'll make these black and just give them dots as the line style. And now I think that if we call all of this stuff, we should also be able to see the data points. So that shows us that, I mean, the data points are very close to each other, so that's why they overlap a lot. But we can see there are some spread here, and you can visually here get an idea about how the standard deviation relates to how spread out the data is. So this is how it would look here. I would actually generally recommend that you, if you can, that you think about including the standard deviation. I think not the standard deviation. That you think about including actual data points in your plots. I think it makes it more, to my eye, this is a little more approachable than just looking at the standard deviation. Even though I feel I have a pretty good understanding of how it will typically relate to data, I think just looking at the data points like this can also tell us something. Maybe we could tell us something if there was like outliers or stuff like that. But that's a bit of a matter of text. But this is how we can use these functions to do a plot, at the very least. And you can, of course, remove this if you are not interested in this stuff. Okay, so with that out of the way, I think we are done. Cool. So good luck with these exercises. Don't be afraid of consulting Google if you are unfamiliar with how to use certain operations, or consult ChatGPT. It's fine for this course to ask ChatGPT about how Python works. Just don't ask it how to solve the exercises. Although I wouldn't assume it could solve these exercises in one go, but you never know. It's ChatGPT, and it's tough. Okay, so best of luck, and yeah, I'll see you again for the last exercise later.